Hello Year 10, this is Mr. Thomas coming at you live from my dining room, and today's lesson is about plugs and fuses, continuing our theme of electricity in the house. And if we were in school right now, you'd be sat in pairs, you'd each have a screwdriver and a plug, and I would teach you how to wire a plug. And unfortunately, we're just going to have to do it by looking at diagrams and how to label them. And we're going to talk about fuses and what their use is and how do we determine which size fuse to put in an appliance. Please take note of some of the key words over here on the right hand side. You'll need to know all of these words at the end of this unit. So a little starter task for you. Have a look at this rather silly picture and see if you can identify up to 10 hazards that are going on in this picture. Pause the video now and give yourself 60 seconds. Off you go. Okay, so there's several there. There's some geezer sticking a knife into a toaster. That's a bit of a hazard. Some lady sticking a screwdriver into a plug socket. That's a bit of a hazard. Watering plants by a computer is a hazard. Having a cup of coffee on your computer is a hazard. All of these wires along the floor is just asking this young lady to trip up with her tray, etc. Right? The fuse box is open. There's lots there, okay? Right, so the first part of this lesson is about wiring a plug. I am not in any way encouraging you now to go and get a screwdriver and undo the nearest plug. You're just going to have to take my word for it that if you took the lid off a plug, it would look like this, okay? A UK plug has 3 wires. The blue wire is the neutral wire. The green and yellow wire is called the earth wire, and the brown wire is called the live wire. Next to that is a fuse, and they will always be in this orientation. They are held together. The 3 wires are held together in another piece of plastic, and it's screwed into the plug via what's called a cable grip, which stops it coming out if you trip over the wire or if someone pulls it, etc., etc. Okay, you will need to reproduce this diagram on a test or exam. The brown wire, the live wire, carries the current, and if you touch that, your hair will spike up. We'll talk about that later. The earth wire is for protecting the appliance and your household electricity system. It stops anything becoming live. It has 0 volts running through it, and the neutral wire will complete the circuit. It's also kept at 0 volts and carries away the current. Okay, notice that they're all encased in plastic. That's because plastic is a poor insulator of electricity. That's important, and it's cheap as well to manufacture. The actual wire itself is copper wire. Again, that's cheap, and copper is an excellent conductor of electricity, and that is why we choose that material. The fuse is a very thin piece of wire which melts when the current exceeds a certain point, which we call its rating. In Britain, we have 3 types of fuse: a 3 amp, a 5 amp, and a 13 amp fuse. Once they blow, once that wire melts, that's it. They cannot be used again. They need to be replaced, but they're very cheap. And as it says there in bold, they prevent fires, not electrocution. Okay, you only need 0.1 of an amp to stop your heart, which is quite worrying, really. So to calculate the size of fuse an appliance would need, you can use this equation here that we've already met before. The electrical power measured in watts is the voltage multiplied by the current. Right? A nice little triangle formula there. The power rating of an appliance, as I've told you in class, is on a sticker on the appliance itself. We already know that the voltage in every house in the UK is 230 volts, so that would never change. So to work out the current that an appliance requires, you just do the power of it divided by 230. For example, if I had a toaster, which is rated at 920 watts, if I do the power 920 divided by the voltage 230, that comes out as 4 amps. Now the question says, Jane fits a 3 amp fuse to a toaster. Well, that would be no good. Because the current going through the toaster is 4 amps, that fuse would melt immediately, so she needs the next size up, which is a 5 amp fuse. So your first task today is to just fill in the blanks, this little paragraph about fuses after we've just spoke about it, and then work out the current that is required for each of these 3 devices, the kettle, the TV and the microwave. So do the power divided by the voltage, write down the current, and then determine which fuse you would need. Don't forget, you need the fuse that's the next size up. For example, if your current was 4 amps, you would need a 5 amp fuse. The 3 amp would blow. So I'm going to invite you now to pause the video and spend 3 to 4 minutes on this task. Okay, thank you. Pause. Welcome back. So I'm sure you filled this in quite easily. Fuses are thin pieces of wire. When the current gets too high, the fuse wire melts. I think I've just lost my pen. We say the fuse has blown. Fuses are rated in terms of the current that causes them to melt, and these are 3 amps, 5 amps and 13 amps. Okay, right, okay, I don't know if you could see that red thing in previous slides. And over here, the kettle, the current for the kettle is 11.3 amps, so that would need a 13 amp fuse. The current in the TV was 0.65 amps, so that would need a 3 amp fuse. And the current in the microwave was 3.1 amps, so that would need the next one up, which is a 5 amp fuse. So I hope you are ticking them off. Okay, now this picture here is something that we never want to see, and this is what you will look like when you get an electric shock. That's a joke, you won't look like that at all. Our body is at 0 volts, like the earth, and if we touch the live wire, there will be a large potential difference across our bodies, and the current will flow through us, and that gives us the electric shock, which could potentially kill. Even if the switch is off, there's still a chance of an electric shock. Even though the current isn't flowing, there's still a potential difference in the live wire. So do not touch it. Contact with that live wire would lead to current flowing through your body due to the current and the link with Earth. Right, a little question here. Which plug has been correctly wired? And you may initially say none of them, because where's the blue wire? Which I don't know why, but this pink is meant to be blue. So a strongly worded email to the person who did this slide. Yeah, so please, the pink wire should be blue. Which one is correctly wired? Have a quick look at that. I'm sure you've all got it by now. It's E. Okay, so the live wire to the right, the earth in the center, and the neutral on the left. Which fuse would be used for each of these appliances? So this is just like the task you did a couple of minutes ago. Do the power divided by the voltage for each one to work out the current, and once you know the current, you can pick the appropriate fuse. Notice the voltage has changed slightly here to 240 instead of 230. Doesn't matter, you still do power divided by voltage to work out the current. So I'll ask you now to pause this for, what do you reckon, 2 minutes tops, to work out which fuse goes with each of those appliances. So pause now, please. And I'm sure you worked it out correctly that the drill and TV have a 3 amp fuse, the toaster has a 5 amp fuse, and the kettle has a 13 amp fuse. So your final thing I'd like you to do today is please make sure you can reproduce this diagram in color, right? So find a blank bit of paper and without looking, have a go at reproducing that diagram. And then jot down the answers, please, to these 4 questions. And if you can take a photo and upload it, that would be great. I will mark them and give you any applicable feedback. Talking about the wires going into a plug, suggest giving 2 reasons the material for X, which is the casing of the wire. Suggest giving 2 reasons the material for Y, which is the actual wire itself. Why is it important to secure X under the cable grip? And what is the fuse for, and what sizes can it be? And all of the answers to that have been discussed during the last 10 minutes. Okay, so that's quite short and sweet, but that's all for today. As I said, please upload any work you do, and I will mark it. And then hopefully next Monday I'm going to do a live lesson with you. So keep your eyes peeled, please, on Google Classroom for that. Right, all the best. Take care. Stay safe, kids. Bye-bye.